Okay, so for Johor paper 1, question 7 is a quadratic function questions. And for questions A, there's several errors or in the questions. Since there is quadratic function, should be a square there. And there should be a positive. According to the mark scheme, it should be a positive. Then if it's a negative, the question is not solvable. So please amend these questions. And this form is given as a vertex form. We need to change it into intercept form. So we can use two ways. One is just sub fx equals to 0 to get the x-intercept or the roots. Or in another ways, we can just simply expand the vertex form into general form and we factorize into intercept form. So we can start to do that. For questions A, fx equals to negative 2 x plus 1 over 4 square plus 49 over 8. So expand it. And eventually you'll get negative 2x squared minus x minus plus 6. And this is so-called as general form, which is in ax squared plus bx plus c. And to factorize out the general form, if you want to use calculator, it will be much more easier when we just factorize out the negative first. So we try to factorize out the negative first to avoid mistakes, okay? To avoid making mistakes. So negative, I will just factorize negative out and get the 2x squared plus x minus 6. So I will factorize 2x squared, x, and negative 6. So for this, I will get x minus 2x minus 3 and x plus 2. Yeah, that's it. Okay, so according to the marking scheme, you also can write this as negative 2x minus 3 over 2 and x plus 2. And this is acceptable also. And don't forget your negative. That's why I factorize out the negative first, because when you do factorizations by using calculator, you have a high tendency to forget to put negative. Yeah. So if we apparently different when without negative, because without negative it will be a U-shaped graph, and with negative it will be an N-shaped graph. So both answers acceptable. You got 1 mark when you got general form, and you got 1 mark for your final answer. Then for question B, it's 2 part. So question A is given that the quadratic functions is given in a general form. Yes, this quadratic function is given in general form, and they want to ask us about the generalizations of the shape of the graph. Means how the shape of the graph changes when the value of a changes to negative 8. So you need to know what's the effect of a. Yeah, what's the effect of a on the shape of the graph? A is actually stretching up the graph, but in other words, it would be in terms of shape, you can describe it as it affects the width. Yeah, it affects the width of the graph. So I will show you his animations by using a graph calculator. So this would be a y equals to x squared graph. Y equals to x squared graph. So see how the graph changes when the value getting bigger and bigger and getting smaller, smaller and smaller, then eventually getting negative. When y equals to negative x, it will be the n-shaped graph. Okay, it will be an n-shaped graph, and when getting more negative, the n-shaped graph will be, the width of the graph will be getting smaller and smaller. It will be stretched out. And when it's positive, when it's getting more positive, when it's getting more positive, from 1x to 2x to 3x and so on, the graph is stretched out. So the width also decreases. So the width of the quadratic graph decreases when the positive graph, the positive value getting more positive, or the negative value getting more negative. So back to our questions there. So it's a negative graph. So it's from -1 to -8. So it's getting more negative. So it's getting more negative, the n-shaped graph looks more, the width will decreases. So for example, the original graph looks like this, then after it changed into -8, it will be narrow like this. Okay, that's just an example, and it's clearly shown in the animation just now. So just simply describe it as the width of the graph decreases since that it's getting more negative. So for question 2, if the graph moves 5 units upwards, determine the maximum point. So if the graph moves 5 units upwards, the maximum point will also move 5 units upwards. Okay, so it's the same, because when the graph, this is a transformation of the graph. Regarding the translation of the graph, you can just express it in the vertex form, and yeah, the maximum value or the minimum value will determine the translation of the graph. So in other words, the maximum point will change also. Okay, so when it's an n-shaped graph, when your graph move upwards by 5 units, I render it as +5, and your value of maximum value will also move up by 5 units. So we need to get the maximum point. Yeah, so maximum point, the x coordinate will remain, but the y coordinate will +5. Remember this. The y coordinate or the maximum value will +5, but the x coordinate for the maximum point will remains. So we need to find the maximum point from the general equations. So the general equations is fx equals to -2, negative x squared plus 4x plus 12. Negative x squared plus 4x plus 12. So this would be the general form. And in order to get the maximum point from general form, so the conventional method is just to completing a square and express it into a vertex form to get the maximum point. But we have alternative way, which is using -b/2a. So the concept of -b/2a to get our x coordinate for the maximum point. So our x coordinate for maximum point would be -b/2a. So -b would be 4, a would be -1. So I would get 2 for my x coordinate of my maximum point. So how about my y coordinate? You can sub the x equals to 2 inside the function to get your y coordinate. So your f2 would be -2 squared plus 4, 2 plus 12. And this would give you 16. So your original coordinates is 216. After adding 5 unit or moving 5 unit upwards, your final coordinates, your final maximum value will change. Okay, the x coordinate remains, but this will +5 for my maximum value. So my final answer should be, therefore the maximum point. Yeah, so therefore the maximum point would be equals to 16 plus 5 would be give you 21. That's the final answer. Okay, you can just ignore this because I just want to show you that this is the original maximum point. So for question B, you got B1, you got 1 marks for your explanations. For B2, you get 1 mark for x coordinate, and final mark for your maximum point, which is M1. Okay, that's all for question 7.